floor standing speaker that sounds nothing like any other floor standing speakers I've heard before. The Clarity 66 speaker started as a discussion between Peter Lyngdorf, the founder of our mother company, and Lars Risbo, who is the main engineer on this project. They had a discussion which came from an idea Peter had about doing a floor standing speaker, but as a normal two-way system. So normally you would only do compact speakers most of the time as a pure two-way system. Because once you move into big floor standing versions, you would expect low-end performance that is much better than what you get normally in a two-way speaker. And once you start to have that low-end performance, because the two woofers move exactly the same, both of those woofers would have to do the mid-range. And normally when you move these woofers a lot to get the low-end performance, that ruins the mid-range. It simply causes distortion in the mid-range. But that is something that these Purify woofers can do that I think no other woofers on the market can do. They can move a lot without distorting the mid-range. So Peter's idea was basically, let's do this floor standing speaker as a two-way speaker with these Purify woofers. Maybe we end up having the punch and timing and dynamics that you get in a two-way speaker, but still having the low-end performance that you would normally require a three-way system to achieve. And I think we succeeded in making that. So you sort of get the best of both worlds in this.
We zeroed in on taking all the good qualities from a 6.2. So we want more of all the good. We want more bass extension. We want simply lower distortion in the bass and mid-range, give it more headroom, and do the best floor standard we can do still at an affordable price point. So the end of that process was that we said we have two woofers, essentially extending the 6.2 with an extra woofer, and then run it as a pure two-way system, which to many will be a bit of a surprise, but there are actually quite good reasons for doing so. Traditionally, you would do a 2.5 way where you let the two woofers work together and share the load at base frequencies. But the challenge here is that you introduce another crossover point. So you're actually adding a delay to the low frequencies, which we feel is compromising this timing accuracy and slam and dynamics you have from good two ways. And actually, if you just simply let the two woofers run in parallel as a pure two-way, you're getting a little bit of this line array effect where you mitigate the reflection. And then they share the load all the way up to the tweeter. That means you get even lower mid-range distortion, and you simply get more headroom. And you only have that high crossover point at around 2.4 kilohertz. I think a lot of people thought we were a little bit crazy, but after we heard it, said that this is really the right solution. So that simply works surprisingly well. The big challenge was thrown, and that was thrown from Peter Lyngdorf, was he said, "Oh, can you do this with a port?" The technical fact is, doing a small box going deep like we have on the 6.2 or 4.2, the passive radiators is really the only technical solution you could do, because going deep in a small box would require a long and convoluted port. But now we are on a floor standard, we can allow a bigger volume. So actually scale up the volume so we have about 27 liters per woofer. That helps tip the balance where a port actually starts becoming feasible. So that started some research and development looking at port shapes. The problem is when you have fast air that meets slow air. So of course you have slow air out in your living room, and then you have the air blasting out of your port. And here you get a transition from this fast air that meets the slow air. And that's where air is nonlinear, and you get this drag between the slow air and the fast air. And then you get this turbulence or vortex formation. So essentially, we had to rethink a little bit and look at shaping the port so that essentially the air velocity has a chance to lower and expand in a full hemisphere. So you don't have these zones where fast air meets slow air. We used finite element analysis to optimize port shapes. And the end result becomes what we nicknamed it a super flare, because it's a very flared shape, because we really want the airflow to go out in a full hemisphere, so that you don't have a sharp transition to slow air.
So what we can do with this port is, as in a normal ported system, we can do a floor standing speaker that has high sensitivity, can go super deep in the bass, and you can turn up the volume without the port becoming a problem. Normally, when you turn up the volume on most other ported speakers, the bass port will start making a lot of distortion and chuffing noises, things you can actually hear. And it will also start to compress, which means that as you turn up the volume, the bass that you can hear from the speakers is getting less and less, or lower and lower in volume. And for these speakers, that's not the case. So you can say that we've made a ported speaker that is doesn't really sound like a ported speaker, but has all the advantages that you would normally get. And that means we can do super deep bass down to 30 hertz at 97 decibels with less than 1% distortion.
The method we use at Purify is very heavily simulation and modeling based. So essentially, we build it as a digital twin model long before we have sawdust and start gluing any hardware together. And the things that are hard to change later on, that's the activity pattern and bass, and the bass response. And that's where these computer models play a huge role, because essentially we build a system including crossover, cabinet, and drivers, and optimize that as a digital model. Another point is that bass response is quite difficult to measure acoustically. So these models are actually really precise at low frequencies, whereas acoustical measurements, they start becoming very accurate when you go higher up in frequencies. So therefore, we are using this split where we trust the models at low frequencies and we trust measurements later on higher up. And that's probably a quite atypical design process, but it's a way to get it right from the beginning.
Everything was measured and computed and worked out. Nothing was left to chance. So that, of course, took a long time to get right. And from there, we do all of the production in Denmark. We assemble the speakers in Denmark, in Nørager to be precise, and we measure them there and make sure everything is right as an end test before we also box them and send them out from there. And of course, the Purify woofers as well are made also by hand in Denmark, in Roskilde.
So going a bit deeper into this model-based methodology we use. So it's actually 3 main models that are coupled together. There's the model of the whole cabinet woofer port model. Then there's what we call the baffle step, or the radiation profile. The third element of the triad of models is actually how the crossover filter interacts with the woofer. So we put all these 3 models together and run that as a concurrent model, and then we wrap an optimization process around that. So we kind of build it up from the base, and then we adjust and fine tune higher up. And I find that is a very effective design methodology.
Almost everything in these speakers utilize the best of the best that we could find. Because once you have the best woofers, for example, you need to have the best tweeter to go along with it. The cabinet needs to be of the highest quality because otherwise the cabinet will be the bottleneck, and so on and so on. But of course, it doesn't stop there because in theory, anyone can buy the best woofer, the best tweeter, the best cabinet they can find for money and throw it together and have a speaker that works at least. But there's so much other stuff going on when you make a speaker. It's a long list of compromises and problem solving that does require a lot of knowledge. And here's where the partnership with Purify comes in, because Purify helped us to do the system integration. So they made everything in the speaker. They made sure all the parts fit together. So you sort of get, of course, the best raw materials, but you also get probably the best engineers in the world to integrate it into the final speaker. And that shows on the result. You can hear it immediately when you sit down to listen to these speakers. The performance of the Clarity 66 is at a level where I would normally think the price tag would be or should be 2, 3, or maybe even 4 times what it has ended up being. And that is, of course, a combination of a lot of factors. We have very efficient logistics and production. We do direct-to-consumer sales. But it is also a part of our heritage. It's something that I know is near and dear to Peter Lyngdorf's heart and has been from the start, that it's pointless to make the world's best speaker if the price tag is so high that nobody can afford to buy it anyway.
Yeah, to summarize, I'm really pleased with how Clarity 66 turned out. When you have a lot of rhythmic content at very deep bass, and the speaker can actually respond and resolve to that makes it very engaging to listen to, and I think I trust that many people will enjoy that. So I'm very pleased with it.